Hi everybody, today we're going to go over our quiz about Science 101. Alright, so the first problem is talking about rounding to the nearest hundredth or second decimal place. So that means we're going to chop off everything after the second decimal over. Now to round, what we're going to do is look at the next number right behind. If it's a 5 or greater, we round up. If it's 4 or lower, we round down. So since that is a 5 right there, I know I'm going to round that 4 up, 2.35. Let's look at this one. We're going to keep everything over there. It's a 5 next to that 4, so we're going to round up, 78.75. All right, so those two decimals there. 6 is greater than 5, so I'm going to round up. There we go. And for the next ones, we're looking at scientific notation. So the format for scientific notation is a number between 1 and 10 times 10 to a power. Since this has to be between 1 and 10, I'm going to look at this number and I'm going to stick the decimal right there, 2.308. That's a number between 1 and 10. Now, right now the decimal's right there. I got to figure out how many spaces I have to move it over. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go times 10 to the 9th. All right, number between 1 and 10. Mr. Lee is not here. He might be in Mr. Musalam's room. Okay, so we're going to go 3.6. Sorry about that interruption. 1, 2, 3, 4, 5, 6 times 10 to the 6th. All right. Now, when we have a very small number like this, we're going to go times 10 to the negative. Very small decimal, again, times 10 to the negative. All right, I'm going to change this to 3. So I got to go 1, 2, 3. 1, 2, 3, 4, 5. Okay, that would make it 4.35. Always double check to see that these numbers are between 1 and 10. All right, let's keep moving. Okay, so for number 3, convert the following from scientific notation to regular numbers. So we're going to move the decimal 5 spaces over. 1, 2, 3, 4, 5. And I'm just going to fill in with zeros. 3, 4, 5, and 3 zeros. Okay, now we're going to move over to 1, 2. All right, so it's just 634. This time, since it's negative, going the opposite direction. I'm going to go 1, 2, 3, 4, 5, 6, and fill in with zeros. I'm going to rewrite it for neatness sake. There we go. 1, 2, 3. So it's 0.001003. Always keep all these numbers. Okay, you don't have to round in scientific notation. Let's move on to number 4. Express v in terms of the other variables. The easiest thing to do is switch diagonal across the equal. That's the easiest way to do it. If you want to know how we got there, I will show you. V is being divided, so I need to do the opposite. I'm going to multiply. And what I do to one side, I do to the other. The v's cancel out, and I got VD equals M. All right, we're solving for V, so I'm going to bring D to the other side, and you see, again, we get the same thing. So you may as well skip some steps and just do it the quick way. Okay, so we're going to use the above equation again, D equals MV, and we're going to solve this time for M, and we get actual numbers. So D is 26. I'm going to put that in D's place. V is 3.4.
Ms. Momono, please call the main office. Ms. Momono.
And we're solving for M. Since 3.4 is being divided, we're going to multiply. Okay, so I get M equals 3.4 times 26, which is 88.4. All right, for number 6, that's simple calculator entry. So in your graphing calculator, you put these parentheses. Don't skip those. 4.5 division sign 2.9. Same thing over here, 2.3 divided by 1.8. This gets a little tricky because now we have scientific notation. So I'm going to put an extra parenthesis there. Okay, so one extra one, so I make sure it's in a different compartment. Rather than x times 10, I just put an e. The e button's on your calculator. And on graphing calculators, it's usually a double E, right where the comma is on your calculator. And I'm going to put that to the third power divided by 37. And when I do that, I just hit the equal sign. Oh, don't forget to close your parenthesis there. And I'm going to get 241.5 if I was going to round it. All right. Number 7, you're going to make a graph. First thing to remember about graphs is to give it a title. So I got a bunch of plants and I'm growing them in different conditions. Okay, so I'm going to say these are flowers grown in sunlight and shade. Since there's two ways I'm growing them, I know I'm going to have two parts to my graph. So I'm going to make a key, and I am going to say that the solid bar is going to be for sun, shaded is going to be for shade. All right, and the largest number I'm going to have to graph is about 15. So when I number up, I want to make sure that I number to about 15. So I'm going to label my axis. So this is the height of the plants. And always include your units. And I'm going to put all the different kinds of plants at the bottom. Since these are words and not numbers, I'm going to use a bar graph. If these were numbers on both sides, a line graph would be appropriate, but in this case, it's not. So what I'm going to do is I'm going to put all my, sorry about that. We're going to put our plant types right across the bottom. Okay, and for each plant, I'm just going to have 2 bars. So you want to graph up correctly to the right number, and just make sure you number up evenly. Okay? So notice I'm skipping 3. And I make sure that every time I skip the same number of boxes. Alright, now it turns out the most tolerant shade plant, if you go all the way up and look how they did in shade, the best plant seems to be the gladiolus. It didn't matter if it was in the shade or the sun, so it's very tolerant of shade. Tolerant means it can grow well in shade. Okay, it's not bothered. And the tulip had the lowest height in shade, so it did not do well. It was not tolerant of the shade. And that's it, so thanks for listening.